chemical bond that is formed due to mutual or equal sharing of electrons between atoms. That's how you define a covalent. Now, what does that mean? So, for example, if we have H2 molecule, so H2 molecule is made up of two atoms of hydrogen. And since both of these atoms, they have one electron, so if you draw the structure, nucleus and one electron here, nucleus and one electron here. So basically, they can share one of these electrons together. So how do we draw it? We draw it like this. There has to be an overlapping area where we show two electrons being shared between two nuclei. And this is basically a shared pair. So that's how they stay together. So they're kind of working in a partnership where each of these electrons or atoms decide to have one electron being shared with the other atom. So they can mutually be stabilized. They can be happy. That's what a covalent bond is. Now, we can show it through a dot and cross diagram. That's what we did here, where we have to show a valence shell. Okay? That's the valence shell. And then we have to show an overlapping region. Kind of, mathematically, we can say this is somewhat similar to that sets and Venn diagram. You might have heard about that, right? So that's that part. And then what's so special is we can also show it through this, a line. That's a single line, a small dashed line. It shouldn't be a dotted line, it should be a solid line, but it has to be a small line. Now, that's a covalent bond. Now, in this definition, what's unique is, both the atoms are equal partners. So if one of the atoms contribute one electron, the other atom has to contribute one electron as well. It's not like only one of the atoms is going to contribute an electron. No, it's not like that. Both of the atoms has to contribute one electron if any one of them is contributing one. Do you guys get this? Okay. Then in the next phase, we can talk about, you know, about an example of CH4 molecule. Now, the different thing here is that we have carbon and we have hydrogen, which are basically two different atoms. Now, carbon belongs to group 4 of the periodic table and hydrogen belongs to group 1 of the periodic table. That means carbon has 4 valence electrons. So if I draw it like this, so 1, 2, 3, and 4. And hydrogen, since it belongs to group 1, so it has 1 valence electron. So once they decide to pair, so what can possibly be pairing, criteria? So the pairing happens with each hydrogen being attached to one of these valence electrons. That's how it goes about. So basically, we have to have 4 hydrogen atoms bonded to one carbon. So the structure becomes somewhat like this. Hydrogen being overlapped here, dot and cross, that's carbon. Here, dot and cross, here, dot and cross, here, dot and cross. So now, this is a single covalent bond or a covalent bond between carbon and hydrogen. So each of these red lines, it represents one pair of electrons. Okay, that's one pair of electrons. That's one pair of electrons. Do you guys get this? Is this understood? Okay. Now, following the same analogy, what I want you guys to draw for me is how do you work about H2O molecule if hydrogen is from group 1 and oxygen is from group 6? So draw this structure and send the answer to me on my WhatsApp. No, Hassan, we can't use 2 carbon atoms because the molecule itself is given that CH4. It's not like C2H4, right? So we can't use it because only one of the carbon is there. So the understanding here is that I will give you the molecular formula and then you have to draw the structure. Okay. So H2O ka you have to complete it and send me the answer on my WhatsApp. Hassan, what a H2O molecule? So we have an answer. That is a very good structure here. Vastani, I think Kam saying here. So we have 6 electrons of oxygen and 2 electrons. That's a wonderful job. That's nice. That's great. So the structure, I have to wait for Hassan as well. Meanwhile, Bushra, you can also try doing the structure of CCl4, where this is carbon, that's 4, and that's chlorine, which is group 7. That's a halogen. So how would you draw the structure of that? All of these molecules are part of your syllabus, and all of these molecules basically have so far been asked in your CIs, both IGCSEs and GCSEs. They have received this structure from Hassan as well. That's nice. That's good. So I think both of you guys are doing very well. Now, all of these examples, whether it's CCl4, which would be looking something like this. So that's 1 for carbon and 7 for chlorine. Is somewhat like this here again. All of these are chlorine molecules. Okay? So that would be the structure. Water is non-protective. All of these examples, they discuss basically single covalent bonds. Now, what is a single covalent bond? See, single covalent bond is a covalent bond that only had one pair of electrons between two atoms. Okay, one pair of electrons between two atoms. Now, what do I mean by that, between two atoms? So just focus here. If you kind of go through this, basically it's one pair of electron between carbon and chlorine, right? And if it's one pair of electron between carbon and another chlorine, not the same chlorine. So don't get confused, sir. Basically you're saying chlorine and chlorine again. So chlorine has basically been sharing two pair of electrons. It's not like that. Both of these atoms are different atoms. Similarly, if we proceed here, that's another atom. If we proceed here, that's another atom. All of these are different atoms. You guys get this part? So that's a single pair of electrons. Now, the other part is, what if we plan to have a double covalent bond? So a double covalent bond is basically going to be formed when we have two pairs of electrons being shared. So a simple example would be an O2 molecule. So if we talk about oxygen, we know that it belongs to group 6, right? So we can have oxygen here, and have oxygen here, that's 6 electrons. So oxygen 1 and oxygen 2. So now each of these oxygen atoms contributes two pair of electrons. So that's 2 electrons from each side. So 1, 2, 3, 4, 5, 6. That completes 6 from for this oxygen, and that completes 6 for the other oxygen. Do you get it? Hassan, yeah. It is not, no, it is only between two non-metals, not metal and a non-metal. I'll still come back to that later on because we haven't studied what a metal is supposed to be. Okay, this is one of the examples. Similarly, if we talk about CO2, that's another example. So carbon has 4 valence electrons. So, and there are 2 oxygen atoms surrounding. Each oxygen kind of surrounded here. So let's, show only carbon's electrons. So that's 2 electrons. Now these 2 electrons are for each oxygen. That's oxygen 1 and that's oxygen 2. Okay. So that's CO2. Now, as you guys remember, we talked about showing or representing a single covalent bond through a single line. So a double covalent bond would be represented by 2 lines. Make sure you don't make an equal to sign. That's not an equal to sign. These lines are far more, longer than that in the equal to sign. So please don't try to write O is equal, 0 is equals to 0. You have to write O, a bigger line, set of line, and then take it. Similarly, here, what you can do is something like this. We get this? You understood? Yeah, sure. So basically, when we talk about beta double covalent bonds, so each of the atoms in the bonding, they have to contribute 2 electrons. See, these 2 electrons are coming from this carbon, and these 2 electrons here, the cross ones, are coming from oxygen. So now they're not sharing only one pair of electrons, but 2 pairs of electrons, right? We get this? That's 2 pairs of electrons. So the only difference between a single covalent bond and a double covalent bond is the number of pairs of electrons. So if we have 2 pairs of electrons being shared, that's a double covalent bond. If we have one pair of electrons being shared, that's a single covalent. So if I ask you to draw the structure of SO2, would you be able to do it? Yeah, that's basically relevant to having octet being completed. That's a very good question. See, how can we know how many electrons are to be shared? So just think about it. इसके ऊपर बाद में जाएंगे अभी याद रखें. Is carbon having 8 electrons in total after forming all of these bonds? So let's count. 1, 2, 3, 4, 5, 6, 7, and 8. Yeah, that's correct. So if we end up, showing carbon like this, for example, if we plan to, kind of just show electrons like this, ये कार्बन के बना लेते हैं 4 और यहाँ पे ऑक्सीजन के बना देते हैं ठीक है 1, 2, 3, 4 and 5 and 6 3 and here. So that's not stable anyway, right? Because carbon doesn't have 8 electrons. So let's count it. 1, 2, 3, 4, 5 and 6. So that's not possible. So how would we know whether it's a double covalent bond, a single covalent bond? We need to see whether after bonding each of these atoms, is it having 8 pair of electrons? So if that's the case, if it does have 8 pair of electrons, okay, that's well, fine and good. That's what make it stable. If it is not, then it has to be, changed. Let's, count oxygen atoms. So it's 2, 4, and then basically how many electrons? That's 4 here in total. So 4 and 4, 8. We get this, Hassan? We get this, Bushra? Is this understood? आपकी बात है, are you guys sure? That's nice. Okay, now help me draw the structure of SO2. तो अब I think आप बना लोगे. Let's figure out if you are able to draw the structure of C2H4. Think about it and then draw it. Do I have an answer? Okay, that's nice. Yeah, this should be the case. Right. So let's figure this out. So carbon belongs to group 4, right? So carbon has to have 4 valence electrons. And we now need, 4 more electrons so that we can end up with, basically having a stable atom, right? So this guy, this needs 4 more electrons. So in total, we have 2 carbons and 4 hydrogen. That very much explains that 1 carbon can be attached to 2 hydrogen, right? Is that correct? So let's figure out first that part of the structure. If we draw hydrogen here, if we draw hydrogen here, that's nice, right? Do you guys get this part? That's nice. Now, this other problem is carbon still have 2 electrons that's left, right? That's not paired. So that's 1 here, that's 2 here, and still 2 more, right? So let's draw them here. That's not part of it. So if I want to, bond it with another carbon and I offer 2 electrons from the other carbon, so will this be stable? Think about it. Yeah, I think so, yes. Why is that so? Because there are 4 electrons here, 2 here, and 2 here. That means this guy now have 8 electrons, right? Do you get this? Hassan, let me, get back to you. अभी मैंने देखा ही नहीं है तो मैं बात करता हूँ. Just give me a second. Now for this carbon, we already had 2 electrons here. We can show 1 electron here with hydrogen, 1 electron here with hydrogen. So now this guy is also happy, right? So the structure would be somewhat like this. C, double bond C, and then we have single bonds with hydrogen. So this molecule has 2 types of covalent bonds. One is a single covalent bond and the other one is a double covalent. Do you guys get this part? Is this understood? Yeah, हसन आपने बिल्कुल सही बनाया होगा. Okay. So would you be able to draw the structure of NH3? You can use a periodic table if you want to. TCl5 and then what I want you to draw is the structure of uh, CS2. Yeah. Let's see what would be the answer. You can use help from periodic table. have a restaurant. हसन ने बनाया है that is correct. बेटा हसन आपका NH3 वाला स्ट्रक्चर सही है और CH2 वाला स्ट्रक्चर सही है, बट TCl5 वाला स्ट्रक्चर आपका गलत है. आपका स्ट्रक्चर आ चुका है मेरे पास, तो इसका है स्ट्रॉन्ग. NH3 बिल्कुल सही बनाया आपने. TCl5 भी बिल्कुल आपने सही बनाया. तो नाइट्रोजन इज 1, 2, 3, 4, 5. Each hydrogen here can be drawn like this. That's NH3. Now we have TCl5. So that's 1, 2, 3, 4, 5 electrons because phosphorus belongs to group 5. So now we have chlorine with 7 valence electrons. Then we have CH2 here. Then we have CH2 here. So now everyone gets to understand. Yeah. कि हम क्या करना चाह रहे हैं, right? It's clear to everyone. ओके, सो बेटा लेट्स कीप इट अप टिल हियर. ठीक है, बाकी बातें इंशाल्लाह ताला आपसे नेक्स्ट क्लास में करेंगे. नहीं, इट इज PCl5 हसन, नॉट TCl2. इट इज PCl5. अच्छा, नेक्स्ट क्लास में आई वांटेड टू हैव अ टेस्ट ऑन एटॉमिक स्ट्रक्चर. तो हाउ कैन आई डू दैट? शैल बी कंडक्टेड ऑनलाइन? आप दोनों पाकिस्तान में रहते हो या नहीं रहते हो, या टेस्ट के लिए ऑन कैंपस बुला दूँ आप? बुशरा से तो आई मेट. हसन इज एन ऑनलाइन. ठीक है, हसन तो टेस्ट देने के लिए आ जाओ ना पाकिस्तान. अच्छा, तो व्हाट वी कैन डू, मुझे व्हाट्सएप पे ग्रुप में मैसेज कर देना एक स्लॉट का, कि जिस स्लॉट में अवेलेबल हो. अच्छा, बुशरा आई थिंक लेफ्ट द क्लास, तो मैं ग्रुप पे मैसेज कर देता हूँ. उसको भी कम्युनिकेट करना है, तो फिर हम एक डे सेलेक्ट कर लेते हैं, उसमें हम एक ऑनलाइन टेस्ट रख लेंगे. उसमें I'll share the question paper and then you solve it and then you send me the scanned copy of it. ठीक है, सही है, can do. Well, till then take care. Love.